Well, it's just after 10 o'clock and I think people are still joining us, but we'll get underway anyway with introductions. Good morning. Thank you for spending the next couple of hours with us. I'm Helen Northmore. I'm the head of Digital and AI for the Life Sciences Hub, and I head up the digital health ecosystem for Wales. Welcome to this morning's event. I suspect many of you were with us last week when we covered openEHR from a less technical point of view. If you were there, welcome back. Otherwise, welcome to join us this morning. So we've got about 2 hours and we've got a number of speakers. Just briefly, wanted to say that Digital Health Ecosystem Wales is a programme which is designed to make it easier and faster to adopt digital healthcare technologies. We're funded by the Welsh Government and we're a partnership with the Life Sciences Hub and NWIS. And we're very pleased to support John and all of the work that is being done around openEHR, because we think these are the kind of important conversations around different platforms and ways of doing things that need to happen. We're looking at digital health transformation in Wales. So just a couple of housekeeping announcements just to start. Please can you mute microphone and keep your camera off throughout. The reason for this is that we will be recording the session and we will be putting it online afterwards, and otherwise we had to blur out all of your details and your picture. So please, thank you everybody for putting microphones and cameras on mute throughout the event, obviously unless you're speaking, in which case we'd love to see your face. So there are a couple of people who still haven't put their cameras on, or haven't turned their cameras off. So if you could please, that would be great. And please share questions and comments on the Teams chat. We will have a Q&A session, and so we will be able to ask you questions, and we will be monitoring that. So it's a good opportunity to also put comments, and it is shared with the speakers. Please use the chat responsibly, because it is seen by everybody who's at the event. So.
we've started to do now is work to support programs such as the Accelerating Cancer Program in taking treatment data, chemotherapy, radiotherapy data, and we're looking to store that in openEHR and present that then for NWIS applications. And also then move to something called the shared meds record, which I won't go into too much detail about, but the point is that there are emerging use cases that we can support here, and we'll see where we kind of get to. Now, part of today is about getting a little bit hands dirty, bit of geekery is going to be going on right now. You're going to see a bit of code, you're going to see a variety of different bits and bobs here, and as if by magic, last night 2 tweets made their way to me, just describing how you yourself can get up and running with openEHR. The 2 great guides, one by Diego here, who basically took a headache away from me trying to figure out how you could deploy the open source implementation of openEHR called Airbase, and I should put a link actually up for Airbase. If you Google it, you can find it, but we'll try and put a link up. That's worth checking out. You can just spin that up in Docker really easily. But yeah, Diego's cracked how to do AWS, and Jake, basically, I failed at this terribly. I just lost the will to live. I could not get it working on Azure, but Jake did it, so that's great. So you have an opportunity after this, if you so desire, to spin this stuff up, really try it out for yourself. Download a copy of Postman. Just start cracking on working with the APIs, and start building some stuff. So great, thank you very much for that. That waffle is ended. There's now going to be some serious content with my friend and colleague Ian McNichol.
Cool. So morning everyone. I'm Ian McNichol. I'm probably the worst person in the world to be giving you an overview of the openEHR technical platform. Well, maybe not the worst, but so I'm basically was a clinician. I'm a clinical informatician, but I'm a bit techie. I'm a bit techie, so some people describe this as a clinical hacktitioner. So I probably can take you through the overview. One of the challenges for openEHR, for people coming to it, is that there are some quite unusual paradigms. There are quite unusual ideas that we present you with. So it's not unusual for people from both the clinical and technical worlds to be a little bit phased about what's going on. So I'm going to try to give you just a general overview of how everything, all of the moving parts. And we talked about this in some detail last time round, but just as a very quick idea, the idea is to have this kind of patient-centric, I should say vendor-neutral platform, rather than all of the data being stored inside individual apps, and then we try to hook all those up via messaging like Fire. Let's start to move to a world where there is a separate data store. We call it a CDR, a clinical data repository, that has an openEHR API interface on that we build and share the data models that power that CDR, and then the apps connect to the CDR, or it could be multiple CDRs, via the API. So much of what we're going to be talking about today is around the CDR technology, how you interact with that, and what the APIs look like, and how the whole ecosystem works. So again, one of the critical parts of the openEHR story is this idea of archetypes and templates. John showed you some slides there. The archetypes are the components that we as clinical informaticians build separately. We then build those little archetypes into templates, which are the data set definitions, and it's the templates that we upload into the CDRs. The CDRs are like black boxes that don't have any real clinical data definitions in them until we start to upload these things. And the nice idea about the CDR is that it is essentially a no-code environment. So we build the templates as clinical informaticians, we upload those to the CDR, there's no engineering has to happen, it just works from then on in. We won't be talking today about how you build a CDR. That's down to clever, very technical people. That's real, hardcore engineering. From our perspective, most of the day is about how you interact with that CDR that someone else has built. John pointed to Airbase as an example of a good quality open source version. So if you're interested in how people have actually approached that problem, go and look at the code that they've produced. And that is hard. It's a difficult thing to do. It's not an easy job. what I hope we can persuade you today is that interacting with that bit of kit that someone else has built is actually not terribly difficult. But there are a number of pieces that we'll talk about. The data models that end up inside the CDR are made up of a number of different bits. There's this underlying reference model, which is the basic data representation. It isn't actually particularly complex in terms of what a clinical application would need. It's like the foundation layer. Then we've got the archetypes and templates that define the possible and the actual content. And the other thing we're going to be talking about is the way that we query this system. When you're querying an openEHR data store, you're not actually using the underlying database technology. There is some kind of database in there. It can be anything. openEHR doesn't define what that should be, but we don't interact with that directly. We always use some kind of logical querying layer. There are some options out there, but most of us use AQL, archetype query language, that is based around the reference model and the archetypes and templates. So to query the data in an openEHR data store, you don't actually have to know how the data is physically structured. You don't actually ever see that. So we're working at a layer of abstraction that quite a lot of technical people find quite challenging, because they immediately go, ooh, I wonder how they make that work. I wonder what the table structure is like. And I always say, you don't actually need to know or care. And that seems counterintuitive for those of you from the technical world that are used to knowing this stuff in detail. But it is what makes this a very powerful paradigm. So one of the things that you'll have to get to grips with is the overall openEHR record hierarchy. So at the very top level is this idea of the EHR. So that's the health record for an individual patient. So if you go and look through the specifications, you'll see all of these defined. This is what openEHR defined as a very consistent way for all of the records, all of the patient records have this kind of outline structure. The idea of compositions, which is the kind of commit class. So everything inside openEHR is stored as a composition. Inside that, we've got sections and entries. So we've got this like tree-like structure. And at the very bottom, you've got your leaf nodes that we call elements. If we look at an actual example of something like a nursing observation, at the very top, we've got this EHR object, and that is that's the object that is associated with a single patient. The patient is given a unique identifier inside the CDR, and then inside the EHR bucket have got multiple compositions, which is the data that we have added, the instance data, the actual data that we've added into the CDR, and that is then structured in this very regular way, sections and then entries, and then at the bottom we've got these little elements where the actual data lives. And it's the structures down below in terms of the compositions and the entries that the actual structures that turn something from a generic entry element structure, turning that into a blood pressure is what archetypes do. So working with an openEHR CDR is really what most of today is, right? Think of it as a smart no-code data store which can natively store, retrieve, and query openEHR data via standard API. It is like a giant data tree. All of the data inside the CDR is completely available from a technical point of view. Obviously, there are governance arrangements which may apply, but in theory, you can get access to everything. If you use AQL, you've got this idea of vendor-neutral querying. So it doesn't matter whether you're using Airbase or Ocean's CDR or the Better CDR, they will all work the same way. So we've got this idea of substitutability and vendor neutrality. And as I said before, a no-code deployment. Nobody has to re-engineer the CDR when you upload new clinical content definitions as templates. Obviously, at the basis of this, there is quite a lot of specifications, and a lot of these are actually directed at people who are either building openEHR tools or building CDRs themselves. As a consumer of the CDR or a consumer of the tools, you don't need to know all of that, and Martin and Stuart will take you through some of that as well. But the core bits you need to know about are the EHR, and that's probably the key document that is worth reading, because it does give you a good overview of the kind of patient level view that you're going to be working with. Obviously, you need to know about the data types, you need to know something about AQL, and the critical bit is the REST API. There are also UML diagrams, which are pretty helpful in understanding some of the details, in particular how the data types work. There are some things that you probably don't need to go into. One is the whole section, which is called the archetype object model. That's really for tooling providers, largely. You generally don't need to go into what's called the demographics model because most people don't use that. And then there are some newer things around business rules and task planning that, yes, they may be of interest to some people, but for most of you, you're going to be concentrating on the core CDR specs. Archetypes build up on top of these RM classes. They kind of graft onto the basic outline structure. I think of it as a little bit like the way that CSS classes graft onto, the HTML, the document object model in browsers, if you're working in UI. So they're not straight classes, they're actually object constraints that graft on the end. We won't talk about that, but actually you don't need to know much about the way the archetype building technology works. Ultimately, you end up with an object model which is constructed using the archetypes, combining them with a reference model, and the two work together when you get to the instance phase. So this is the key thing that you probably need to really get your teeth into, is the openEHR REST APIs. I'm going to go through quickly just some of the key bits. So the template resource in the openEHR REST API describes, the templates describe the constraints when you commit a composition. So that's a bit of blob of instance of data to the CDR. When you send that patient data into the CDR, it is validated against the template. So having the template in there is really important. There are calls that allow you to upload new templates or bring them back down from the CDR. One of the tools that you definitely want to get your head around is something called web template JSON. So currently that is available only from the better Airscape API, which is a proprietary API which sits alongside the openEHR REST one. But the Airbase guys are supporting that shortly, and we think it's going to become widely available. It's also available from the free-to-use Better Archetype Designer, so you can get access to the web templates very easily now. It's much easier to read and parse than the official XML-based OPT, which is the thing the CDRs understand, and it lends itself to lots of kind of downstream processing. So here's a little tool that Bjorn Ness and Dips wrote that pumps the web template out as a little bit of, if you like, guidance documentation. So human readable ASCII doc. The HR object, that is that top level object, and when the first thing you get to grips with when you're working with CDR is that you need to register the patient with the CDR by creating an EHR object through the API, associating that with a subject ID, which is in openEHR, we call it a subject ID in openEHR, but that means some kind of external identifier like an NHS number or other national number or a medical record number in a hospital. That generates this unique EHR ID for that patient. It's the top level bucket into which everything else goes. And each session, when you go into a patient record in the UI, you will retrieve that EHR ID for the patient via their subject ID. And if one doesn't exist, then you have to create a new one. Compositions are the next layer really that you need to get to grips with. So there's a set of composition resources. They are the root document for all clinical data. So when you're interacting with a CDR and pushing data in, you're always doing that in the context of a composition. The structure of that is defined by the template. One of the things that you get for free from the openEHR API is this idea of versioning. So when you create a composition, and the REST API will do that, you get back this unique identifier. As well as doing a post, you can also do a put. So if you need to change that composition, if somebody made a mistake or the document needs to be updated, the CDR handles that automatically. You do a put, you send it the previous version, and you get back a new version, and you'll see that little trailing numeric there, that would be updated to 2. So this is one of the big advantages of working with an openEHR CDR. You get that audit trail of changes to data. You get that automatically, very easily out of the box with the CDR. So all changes will create a new version. Similarly, if you do a delete, and there's a delete method on the composition resources, that will delete the composition, but it does it in a medical legally safe way. So it really just flags it as being deleted. One of the things you'll need to get your head around is there are various serialization formats, from canonical to flat to structured. Martin may well talk about that a little bit. This is the structured format. Again, one of the other resources is about queries, and this is all about handling AQL. We can use stored queries, but also you can send an ad hoc text string. Don't worry about the structure of the query. It does look a bit weird, but it is a kind of weird mix of AQL, something like XQuery, so path-based querying, and SQL. And what you get back from that is essentially a result set. So you get a bunch of rows coming back, and the structure of those rows is defined by what you put in your select statement. The really key thing about the queries is you get full access to that whole data tree. Again, governance willing. It really helps to have some tooling. So this is the Better Studio product that lets you build those query language, the queries. They are just bits of text, so you can build them manually, but you have to understand the structure of the templates that you're working with, the structure of the composition data. So having a little tool like the Better Studio tool is really helpful. I understand the Airbase guys are working on something similar, but you don't need that. Ultimately, you just send this string, you create it however you like, and you send it to the backend CDR via the openEHR REST API. So again, just this idea that what you're working with logically is this EHR object at the top, which has got an EHR ID. Then you're basically working through a whole bunch of paths down to this bunch of compositions. And all of this is available to you, including across multiple patients. So you can do things like population querying through the CDR if you want. And coming to that, so obviously people are interested in how you do things like analytics and integration. And fundamentally, it probably is the same as everyone else is doing. You would use AQL to get your candidate reports, but you'd probably offload them through a sort of traditional ETL kind of approach into an analytics DB. There are good reasons for doing that for performance reasons. You don't want to do your heavy-hitting population queries on your CDR because that's going to kill your operational use. So it makes more sense to construct some reporting AQLs, pump that out into a flattened format into an analytics DB, as well as getting, you can then use that for your heavy hitting population queries. But because it's in a more traditional database format, you can use tools like Tableau and Click on top of that. There are some interesting products emerging that make that journey easier, but I'm not going to talk about them today. And again, John was talking about having facades on top of the openEHR AQLs, etc., to handle things like integrations with FHIR or other messaging environments. And this is just an example, open source, that we built a few years ago. We'll give you an example of how that can be done. Okay, that's me finished. And now we hand over to Martin, or is there another question coming up, Helen?
No, Ian, it's your opportunity to introduce Martin.
So hand over to Martin, who is from Staircase 13, and Martin is a developer who has worked with openEHR for quite a while. So he'll give you, I suspect, a bit of a warts and all developer's perspective.
Hi, good morning. Yes, hopefully I will. Just let me get my slide switched over. Okay, so hopefully you can see that now.
Yes, we can.
Excellent, great. So yes, good morning. My name's Martin Lewin. I work for a company called Staircase 13. We're a services provider, software services provider, I should say, and we don't specifically work in medical or healthcare industries. We work across a whole range of industries, but we specialise in mobile app development, mobile and tablet apps, and any supporting back-end systems that you would use to provide data to the end app. So we were first introduced to healthcare about 6 years ago. We were approached by two separate clients at very close intervals. One who were interested in creating a tablet app which was involved with primary healthcare, and one to do with secondary for use for sort of nursing assessments on a ward. And the interesting one turned out to be the secondary healthcare, where they had a great idea, but they really hadn't considered what the back end would be, and they were more interested just in the front end. And during the period of discovery that went with working out how they would actually integrate to a real system, we were introduced to openEHR and introduced to Ian, and had a very similar sort of talk from him that we just heard with all those fundamentals. So we saw the massive benefits that you could get from using a system like openEHR for people who are coming in from an app development perspective, in that you didn't need to understand anything about how the clinical data was going to be stored. You worked with a modeler who could put together the model for you so that you could guarantee that what was being stored was the right stuff, and all you had to do was put it into an API, and it would get sent to the right place. So sorry, I've lost one of my screens. There we go, that's better. So yeah, what I'm going to talk about really now is exactly the same things that just got introduced by Ian, but very much from a developer's perspective. So Ian is up in the clinical modeler level, and he's not really a developer. He will talk to you for a long period about how you can use the archetypes, how you go about getting an international consensus on getting a really good archetype that you can use to represent something, which is a maximal set of data that everyone can use and can be really good for interchangeable reuse. Most of us don't need to be anywhere near that level of understanding of openEHR. So if you consider, we then have people who might be working as a technical architect, and if you're working at that level, you probably also need to understand in reasonable depth some of the bits about the templates and the compositions and the things he's talked about there and the archetypes. But for most of us, we're down in the lower half of my slide there. So either you're a developer who does need to interact directly with openEHR in terms of the repository and using the REST APIs, or for a lot of people, you don't even need to do that. If you're working on UI, you can be really separated from that. And the good news is that despite all of the clever ways that openEHR can work internally and all the things we can use in terms of the archetypes, for those of us on the UI side, it really is just clinical data in a tree structure with some sort of preset paths that you need to stick to. As Ian said, it's very much like an XPath sort of format that you're going to use to represent a point in a hierarchy. So in a little more detail than Ian spoke about, but not much, don't get concerned about the stuff on the right hand side. The point of that being there is just to show you that the OPT, the file that you would get sent from a clinical modeler, is something that you really don't want to ever have to look at sort of manually. So the OPT is the operational template. So that's what we get out of the modeling stage. And as a developer, that would be sort of the first thing that you might receive. And you can load that into a repository. And then you can use the tools such as the template designer or Air Explorer from Better, which allows you to view the model hierarchy that's within that template, create compositions directly in those tools, or create example ones. You can get them to create them for you. And it has the tooling in those products that you can use for building AQL queries and working with the data. But the first step is you always have to have that operational template and load it into the system so that it knows the model. So once you've loaded that in, the other thing that you can do is create a web template from it, and Ian spoke about that a little as well, and we're going to go onto that next. But so for a lot of the examples that I'm going to use here today, we worked on a really simple app which was designed for mental health patients to monitor their physical health, because apparently there are sort of poor outcomes for mental health patients in terms of normal physical health issues because they're less capable of looking after themselves. So as part of this app that we were doing, which was meant to be used for the mental health patients to be able to sort of talk to clinicians, it was collecting some very basic template information such as height, weight, BMI, waist circumference, blood pressure, and some details of some very generic common sort of blood tests results that you might have from your GP. And that's what I use for most of the examples today. But the template for that in the OPT is about 4,000 lines of XML. I mean, it's not something which is intended to be looked at manually, and it goes through and it describes every node within the tree hierarchy and puts all of the limitations on it that can be used for validation. So yeah, we never really want to look at that at all unless you're writing a CDR. However, the web template, effectively all it does is it flattens that tree that we've got, and it takes us as developers to the bits that we really need, which are the leaf nodes at the end of the tree. So what it does is it removes most of the structure that we really don't need to understand. And for the leaf nodes, it gives us the AQL path. So that's effectively like the X path that Ian spoke about. And it tells us what the type of data is that's going to be in that leaf node. So in the example that I've got here, on the right-hand side, you can see there's the blood pressure archetype from the example I've mentioned before. And that's still sort of a maximal archetype in that it allows you to store lots of things to do with the context of where a blood pressure reading came from, which can be very important. But the main thing it stores is also obviously the systolic and diastolic pressure in terms of the magnitude, the units that were used, and the time that the reading was taken. Now, if we look so that view is from the better Air Explorer, and there's a little piece underneath that shows what the details would be for the magnitude of systolic, which I've highlighted, and on that you can see it will give you the AQL path. If we look on the bottom of the screen in the example from the matching web template, you can see that within the systolic bracket you'll see the AQL path I've highlighted, and that is still not very readable, but we don't really need to worry about that. All we need to do is use it. So effectively, if we start using a flat structure for storing, so Ian mentioned having flat or structured documents, providing we're using a flat document structure, effectively all we now end up with is key value pairs, where the key is going to be one of these long AQL paths, and the value is going to be your clinical data in the type that the model specifies. So when we start thinking about it like that, things really get much simpler. So if we look at the different types of entries that we're going to have in this graph, you've got two sorts of structural ones. You've got ones for sections, clusters, complex objects, which are all part of the modeling language from the reference model, and we really don't need to pay any attention to those. You have some for observation, evaluation, instruction, and action, which are useful to understand just in terms of the basic use, and they're pretty much self-explanatory. So an observation would be a blood pressure reading. An evaluation would be to record a clinician saying your blood pressure is too high. An instruction might be the clinician recording a prescription to say that you're going to need to be medicated. So that's the recording the need for something to happen. So it might also be an instruction for medications, medications to be dispensed, or for an X-ray to be taken, or something else like that. And the action would be the recording that something actually occurred. So that would be that you took the medication, and so that action might happen on a very regular basis. So that is useful to understand the basis of that, but you don't need to get into the detail even there. The values are what you might expect. At the end of the leaf nodes, we have values which are either going to be, say, floating point or integer numbers, or date, time periods, or text. And the one that's worth just drawing out is coding. So it's quite common to get coded text, and there's two ways that we can see coded text being handled, or coded information being handled within these models. You can have on the right hand side, the top example is you could just have a local code which can be validated by the model when it's in the repository. So in this case, it's the unit for your blood pressure reading. So this is giving a possibility of a list of different units, but in fact in this case there's only one in the list, which is millimeters of mercury. So that's an internal coding, but also we would be able to snowmedify. I like that term. I'm going to keep that one from John. Snowmedify the values, and so also within that same part of an archetype for blood pressure, we might have a term binding for a SNOMED CT, value, which in that case is the one for the systolic, I think it was. So yeah, we can have all that coded within the template, or we could have something that just says it's coded, and then we can add the codes, when we're creating the compositions. But effectively, when we're working with compositions, all we're doing is we're getting a set of key value pairs with these admittedly fairly awful keys of paths, and reading and writing them with a fairly standard REST API. And I'm not going to go into any of the detail of that. So commonly, after we've written some of these things, as we would with any normal database system, we're going to want to draw that information back, and we're going to write a query. So in this case, the query, as Ian mentioned, is done using an archetype. So the good news is that most of what you see, if you actually have to write these queries, looks very much like SQL would, or any other structured language. So you'll see there's a select, you'll see there's a from clause, a where, an order by, all of that. If you work on any sort of database system, that's going to seem familiar to you, and it should. It really is no different. The difference is, if you look in the select clause, you're going to see a lot of these paths for the archetypes, rather than just a normal sort of column name. And the other biggest difference is that instead of having a from clause which has a series of table names in it, normally the thing that we're drawing from is going to be the electronic health record object, the EHR. Not always if you're doing populations, but if you're getting something for a patient, it's normally going to be from an EHR. And so what we need is a way to constrain what compositions or archetypes we're looking for in an XPath sort of style within that EHR. So you'll see there's a contains clause. So the contains clause can say, in this case, in my example, I'm looking for any composition within the EHR, which then also contains an observation for blood pressure. So already here, we can see that we're just looking for blood pressures for that patient, for that record. So in this case, my where clause actually constrains that to an individual patient. So now I know that I'm just looking for all of the blood pressure readings for that patient. I've ordered them by time, and if we look at the actual paths, you can see that they're just the relative paths for that archetype. So your BA is defined as the observation, so that's within a blood pressure archetype. I only want this data back. So it's all quite self-explanatory. And the power of AQL with this is that using that, I can get all available data. So I can get every blood pressure reading that's been recorded for that patient that's in the CDR that I'm permitted to fetch, regardless of the containing composition that it was in, or who entered the data, or what application it was entered as part of. So that's great in that, from an app perspective, for someone working external to the details of how it's stored, I don't need to worry about any of the design of the database or the indexing or how easy it is to get that information. I can write a query that does that, and in quite a familiar way. The difficulty, of course, the problem is that query that I've just written will fetch literally every blood pressure reading. And though I might have written my simple app that only stores things that have been entered by the patient themselves for a mental health case, and they might have entered one blood pressure every couple of months when they go to a clinic. If they happen to have been into hospital for an operation, and they were connected to an automatic cuff, which is integrated into an app, which is recording the data every 5 minutes, or more than that, when I do my simple query, it can bring back all of those readings. And of course, there's a different context to those readings, because the ones that have been done in surgery or in recovery will have been done using a different method, and so there'll be a lot more accuracy in what's the word I'm looking for? So yeah, you'll have a lot more it doesn't matter. Just trying to think of the word to say that you'll respect the reading a lot more, having a bit of a blank. Whereas something that's been entered by the patient, you obviously won't have the same level of trust for. So you need to be a little bit more careful when you consider the power of the queries that we can make. So in my example here on the right hand side, I could just limit my composition to only being from my clinical observations template, whereby I know that I'm only ever going to get my own data back. That sort of loses part of the point of being able to do these things, but it's the ultimate way to stop that. Or in another example, if I'm looking at body weight, and well, if I want BMI, then I could create a contains query that will look at BMI directly, but it could also find any observation that's got, sorry, any composition that has observations for body weight and height, from which I can then calculate the body mass index. So there's quite a lot of power there, but you have to be careful about how you use it. I'm just going to give 3 examples now of where we've used different technologies with openEHR, just to, I mean, mostly just to demonstrate that it doesn't really, the concept is there, but it doesn't really limit in any way what it is that you're doing or the technologies that you choose to use to work with it. And also to just quickly demonstrate how you can protect downstream developers from most of that detail. And in fact, most of the time we try to hide even those long AQL paths to prevent them being something that everyone has to deal with. So in the first example that I've got, we looked at a prototype tablet application for nursing activities on a ward in secondary care. It was a really big application, and we were only sort of doing parts of it. And what we were looking to do was have an easy way to integrate together from an existing master patient index for demographics, some HR7 and FHIR endpoints for lab tests, etc. And we needed to just pull all this together fairly quickly. So we used an integration engine approach. In this case, we used Apache Camel directly. And that's a technology that allows you to route messages effectively to pass things through the system, and it allows you to sort of dynamically move things around and push your data in and out. There's lots of commercial ones around, but in our case we were using it from the base level. And so what we had to do here is, within some of the processes that we wrote, which are effectively just little processing classes, we wrote code that took messages that were coming in from the UI, the APIs that supported the UI, and just transformed them to match the templates. So it basically was just templating into key value documents that could then be passed through, and then use standard REST calls which went to the openEHR repository. So there's one example. For a second example, which is the mental health application that I spoke about. So in this one, we had very simple app UI. So this was sort of web app or mobile app, which is shown on the right of the example again for a blood pressure record, where we just need to be able to show the results and signpost patients to more information. So in this case, we want to protect that end app entirely from the AQL paths. So what we did is we put a very slim middleware in between, and that was just using templating to replace, if you look in the little box in the center, if we see BMI or BMI unit, all it was doing was taking those simple JSON documents and replacing BMI as it passed it through with the appropriate AQL path for that template, and then using that to create compositions. And it was the same. We had stored queries, and in the queries it would be using the as term, which would be the same as you'd use in SQL to take away the paths and just replace that with as BMI, so that when the result set was returned, it was in a really simple format that an app could use. So for my final example, and I realise I'm just starting to run over time, so I'll go through this quickly. The app that we're currently working on is with Aperta, who are promoting open source in UK healthcare. And we're working on that with them called Open Outcomes, which is for collecting PROMS data, patient-reported outcome measures, and providing a way to automate sending of questionnaires for PROMS. So in these, you get lots of different PROMS questionnaires which are used for different types of procedures or problems that can be sent out at periods to monitor over time whether patients are observing their conditions to have changed after operations. So what we're trying to do in this case is work with two different types of data. We've got the prompts questionnaire results, which are observations and are relatively simple, and we can do the same sort of thing as we did in the previous apps. But we are also working with a care pathway model, because we want to know when a procedure took place, such that we can determine the periods after that at which to send out the questionnaires and present results in such a way that you can monitor things over time.
Right, everyone, I think it's time for us to get back to the good stuff. Hopefully you've got a suitable amount of caffeine. Myself, I'm going for the Pepsi Max route. Other drinks are available. Oh, needed that. So next up, we've got Stuart, who I just love the title of his slides. And it's an important message as well. So hopefully you're gonna learn something interesting from Stuart.
Okay, so what the developer doesn't need to know. The other presenters have explained all sorts of technical details, and there is a bit of a repeating pattern. There's some underlying trends, there's underlying facts that are needed to know by the developer, certainly around templates and archetypes. That's really important. But there's so much more to building applications in the health and care ecosystem that you need to think about in the wider context. So I'm covering those wider contexts, try not to overlap too much with the other folks. The other thing is, in 20-minute sessions, it's not possible to train in openEHR because there's so many concepts in the healthcare ecosystem in general to learn. This is obviously more of a taster. Ian's one of the leading experts, and he can go to any level of depth. But again, this is about the broader picture. So my background, I've been implementing free and open source software into business critical situations since the mid-90s. Found that open source effectively allows me to do whatever I need to. I become the limiting factor rather than a license or a scarcity of software. and we've been involved in open source and health and care community for about 7 years now. Our key mantra is understand the outcome and how to measure it, rather than, before you start any project work, why, what are you trying to achieve? And actually, who's telling you that, and do they know what they're trying to achieve as well? The company, OpenSVL, covers the full life cycle, discovery, design, build, and so on, and there to focus on enabling organisations to have professional access to open source. Why did we choose openEHR? We wanted to apply our learnings from our project with South London Maudsley. They implemented an openEHR project, and although that project is working very well, there were challenges, not necessarily just with the implementation. Of course, software is always easy to look at and think, well, what could I have done better? But actually the overall ecosystem, how can we help it integrate with other applications, and how can we drive best practice from that, from those learnings? So we researched the marketplace through our Ditto project, ditto.tech, and looked at all of the ways we could manage clinical data as developers, not wanting to be clinicians. So although we knew about openEHR, we wanted to reevaluate, just because we didn't want to get caught up in confirmation bias. We wanted to revalidate, is openEHR the right thing? So after looking at the options, then yes, it absolutely is. We were considering the prospective user, developer, customer, and really it was the only option that met our criteria. Following that, we then looked for implementations. As was mentioned earlier, there's many ways of implementing openEHR. It's a standard. We selected Airbase. That was our preferred implementation. The approach we took to the software was that we had 3 points to work to. Point number 1 was the user. The user is absolutely critical. They need to not care about the system. They need to worry about their job and how they can safely and professionally use the application. The data is fixed. openEHR defines the data. It's not up to us to define that. And then you've got third-party systems as well, which we need to interact with and interface with. From the user perspective, the way we think about that is a bit like a dashboard in the car. Whoever's designing that dashboard in the car, their job is the safety of the driver. They're not thinking about the gearbox. That's someone else's problem. And this real separation of concerns is critical in safe health applications. A different approach that we've taken, there's the other presenters are talking around the JSON and the flattened JSON structure. Our team are using the XML directly. We find that it gives us more control and allows us to create more power in the middleware, albeit at a cost. And that's, again, an alternative choice. The great thing about openEHR and Airbase is we have those choices. I won't labour the point on this. I think everyone knows that the answer is both FHIR and openEHR. So what the developer doesn't need to know, based on our work with Airbase, and I'm not familiar with Better. I understand that they're very similar, quite close, but this is around Airbase. The developer's job here is to consume, aggregate, transform, and provide data ultimately to people. Using openEHR and Airbase in this case, but specifically openEHR, separates these 2 key concepts, which is what is the clinical data and how is it stored. Given that, this is an easy one to start with. The developer does not need to define clinical content. There are clinicians, people like Ian, specialists and consultancies who can focus on making sure that the clinical concept is stored in openEHR. The developer's job then is to access that within the given constraints of openEHR and the CDR, the clinical data repository. And the clinical and technical communities can work together to develop that. The next thing the developer doesn't need to know about is other applications. This is quite nice. It means that, so some applications are quite simple. You could create a really simple application to read a piece of data from openEHR to solve a particular problem in a particular local or a national environment in a setting. You could also have a huge complex application set, but it doesn't necessarily matter because the data is stored centrally in the same way. So it makes life very easy. And you can, of course, rebuild on someone's application if it's open source, reuse libraries, but you don't have to. If you have a completely different scale of need, you can build something appropriate for your needs there. Your own application, of course, might be another application you need to think about, because you might be upgrading it and keeping some parts, but maybe changing other parts. Knowing that the data is consistent and you know what to expect is critically important. Other languages, there was a question just then about what languages people use. Well, with openEHR, it doesn't matter, because you can have completely different approaches, different languages, different ways of operating technology. It might be you have human interfaces, computer interfaces, might have machine learning, ingesting and creating new pieces of data. It doesn't really matter. As long as you know what data you need to consume for your application and what data you need to give back, then everything works in an interoperable way. You don't need to know about how to procure Airbase, for example, as an open source implementation. It's a database. It's not free to create software, of course, but the cost of replication is very small. It's too small to measure. So the folks at Airbase then provide that as an open source application. What that allows is it allows you to experiment. There's no procurement barrier to experiment, or no SDK required, or any other barriers. You just get on, download it, install it, and start working with it. And that's really important from that innovator's perspective. So there's no politics or paperwork in the way. The software is, from a platform perspective, it works well with containers. If you're familiar with Docker, that allows the developer to focus on working within that container and not necessarily have to be thinking about the platform. That's the infrastructure IT teams to worry about that. They can worry about the security, the performance. Applications need a level of built-in developer consideration for security, especially in the current day. But from the platform perspective, that's someone else's job. And at the point that you have a container that you can create and you can deploy, you can keep repeating that same process. You can copy the application, you can put it in different places. So it works very well from that perspective. You don't need prior knowledge of the destination platform. The database schema, we're not having to worry about creating tables and specifying fields. Airbase and other CDRs will take care of that for you. So again, you're just focusing on the data itself rather than the mechanics of how it gets there. But of course, it's open. You can explore. There's not a barrier to exploring. It just means you don't have to. Data replication. If you've got a mission critical application, that's one thing, but running it for live operations is a completely different domain. So Airbase is built on Postgres, and that has built-in very powerful existing replication that you can just reuse. That gives you things like real-time replication. RPA recovery point objective can be 0 up to the last transaction using out-of-the-box commodity features. We're using this at a couple of organizations where, for instance, at South London Maudsley, we've got a 3-point replication where you've got your primary services replicated to a secondary in the same site and a third on a completely independent platform. So if your data center, we measure it in the context of if the data center was to vanish, if a plane was to land on the data center, how do we make sure that doesn't interrupt our business as usual? And this 3-point replication provides that. So again, it's not highly complex. It's out-of-the-box commodity functions that you get from Postgres, which Airbase is built on, which openEHR, of course, resides within.